Good day. My name is Martin Halliwell. Welcome to another episode of the Value Engineering Experts. This episode features a relatively young engineer, Brendan Jakubowski. Pretty good resume. I wanted to sample somebody in their 30s. I believe he's in his 30s now, but to look at the issues of over-design, in particular P3s, and talk a little bit about what's changed with the foundation industry in particular. Brendan works for a company called Aecon Foundations, very large group. Anyway, we'll bring him in and say hello to Brendan. Hi, Brendan.
Hey, Martin, how are you?
Good. Thanks again for being a guest.
Good to be here.
I look forward to tapping your brain. You know, you're out in the field every day. So I understand you just came off a job in Vancouver. We'll just shoot the shit for a bit here. You're
Sure.
You're back in Toronto now?
I am. Yeah, I'm back in Toronto right now, which is predominantly where I work and where I reside. But we, in this calling, we find ourselves in many different locations. So had a short term out in Vancouver and a little bit of work in Edmonton recently, and now I'm back home, which is nice.
What was the project in Vancouver? It was a big one, I think, a bridge, wasn't it?
Yeah, the Patullo Bridge replacement. So we did some large diameter drilled shafts to support the north side footings and abutment there.
And you were there for a few months. Typically.
Yeah, about 6 months, something like that. Yeah.
How's Aecon Foundations? I know Jonathan Hasenberg fairly well.
Okay.
Jonathan and I have been associated for a while, and we check base every time something changes. Okay. But so the Patullo Bridge, we won't get into that too much, although I'm going to say I bet you the foundations are monstrous for that.
They were some of the biggest caissons I've dealt with, that's for sure. They were big, almost 50 meters deep, about a 2-meter diameter. They were some big piles. Enough steel in the rebar that you can't really see daylight through it when it's hanging in the air. So it's definitely something to behold.
How many caissons would there be per footing?
Between 4 and 8, depending on the kind of the configuration and where the bridge was at that point. So as it kind of spreads out into a few different kind of arterial connections, obviously they get a little bit smaller. But yeah, there were some smaller footings with what's the new term, multi-use passages on them, the basically bike and pedestrian lanes. So some smaller footings for that, and then the bigger ones were 8 caissons in a row. And
big price tag bridge, like $1 billion or something?
Something like that. Yeah, off the top of my head, I can't remember, but somewhere north of $1 billion.
Yeah. So gut feel, I'm going to ask you quickly about this project. And you're a senior superintendent with Aecon, correct?
I am, yes. Yeah.
So congratulations. And I'll also touch on the fact that Brendan and I have known each other a long time. Do you recall when we first met, Brendan?
I'm trying to think. I remember the first time I talked to you on the phone. I don't remember the first time I met you, although I'm assuming it was at the office there out in Ayr. But I remember I called you. I had a co-op job lined up with a company called Worley Parsons, which I don't think exists under that name anymore. But Worley Parsons doing some concrete design for some sort of natural resource processing plants of some sort. And I think this was 2009, I want to say. And that job got canceled shortly before I was supposed to start. So, I was completely freaked out at that point, right? Because these co-op jobs we had lined up 2-3 months in advance, and all of a sudden this one disappears before my eyes a couple weeks before I was supposed to start. So I had a friend working for a Canadian, I think it was at the time. I'm trying to think of the name. Hanlon wastewater treatment plant. I don't know if that jogs your memory or not.
So he said you should call this company and give him a try.
Exactly. Yeah, exactly. I think he must have met you on site or something like that and talked to you and said, you got to try giving this guy a call. And
I always believed in hiring graduate engineers. I'm glad you had a good experience with us, and I think it influenced. It's a fascinating industry for a young guy to come into.
Mm-hmm. It's not something you get a lot of exposure to in either through life or through school. I feel like it was kind of happenstance that I ended up in foundations. Couldn't be happier that happened. I mean, it's worked out great for me, and I do really enjoy it to this day. But it's not something you get a ton of exposure to. You hear all the kind of the more quote unquote glamorous sides of engineering in terms of steel design, concrete design, some of the softer sides of the environmental stuff, but you don't really, I feel you don't get sold the construction industry through university, and that's kind of a shame, but it is what it is, right?
Yeah, you can learn a lot with the steps you've taken. From that experience, you were Waterloo Civil?
Waterloo Civil, yeah.
And then
I
you went on
graduated back in
to
2011.
went on to Deep Foundations, I think.
Yeah, I went on to Deep after I graduated. So I was a co-op student when I was at Macon. I went to PCL for a little bit. Great company. The work was, I don't know, I guess I missed the foundation industry working there. So I tried Deep afterwards, and I stayed there for 3 or 4 years after I graduated. And I had a great experience there. Really, got into the piling and drilling, tiebacks, lagging, all that sort of good stuff around the shoring industry. All in the Toronto area, mostly subway stations. Seemed to kind of move from one subway station to the other, which was nice. Big projects, lots of exposure, lots of different scopes and that sort of stuff. And I guess at this point we're 2012, 2013. There hadn't been a whole lot of subway spending in the city since, I gotta say, maybe the 90s at that point. So once that Toronto York Spadina subway expansion started, it was a real pile of work, pun semi-intended, for any foundations companies in the city to try to get through. And then that tapered nicely into the Eglinton Crosstown, which is still ongoing to this day, which I spent a lot of time on afterwards. And at a certain point, 3 or 4 years in, I decided to kind of pick up everything and move out to Vancouver. Just kind of more of a change of scenery rather than anything else. And I worked in kind of marine pile driving for a couple of years in Vancouver before coming back to Toronto with Aecon, which was also a great experience. Totally different.
Somehow your family ended up back here. They wanted to return. Most
Yes.
people want to get back. Women want to get back when their parents, when they start having kids.
Yeah, exactly. Yeah. So that was kind of part of the driving factor of coming back to Toronto, was kind of getting married and wanting to start a family. So that was kind of the next chapter that started at the same time as being with Aecon. And I've got three sons under the age of 5 right now. So it's pretty wild at the house.
Yeah, I think you're similar to Chuck Kranz. He had 3 boys. I don't know if you picked up on that, the discussion he was a recent podcast guest, pretty interesting guy, Chuck Kranz.
I did, yeah. I heard that one was great.
So there you go. So you've done a lot of P3s, which is one of the reasons I wanted to get you on the podcast, because I've always had a bit of a bee in my bonnet about what I see on P3s and what I consider to be, less than value engineering.
Mm-hmm. I could definitely value engineering. That,
yeah. When we look at value engineering, for me, it's an actionable verb, measurable noun. It's about, you try to simplify the problem into those 2 things. And we could say move people, or provide trains, or in its simplest form. The issue that I have is that over the years, and Isherwood and other people who were around in the 80s with me and were part of some of the builds, which were actually more in the 70s. Natter, and sorry, great engineer. He'll say to me, Young and Finch, I think it's Young and Finch, is the subway walls are 16 inches thick.
Yeah.
And so
what a change, right?
Yeah, and in those soils, I would think they probably had lagging.
Mm-hmm.
What happened was in the 80s, we Deep Foundations and Anchor Shoring and Frankie recognized the need to put caisson walls next to buildings.
Mm-hmm.
But for whatever reason, we developed that mindset in the last 10 years that everything should be a caisson wall. Hence the diameters got bigger, and the horsepower of the rigs. Maybe it also had something to do with the advent of European equipment.
Mm-hmm.
And the ability to push casing in, and in those days, Brendan, we would try to get away with as little casing as possible. And the minute you sealed off the upper fills, particularly in North York, you might get no fills, but let's say you put a liner in that's 20 feet long, just to control your wedges, really.
Yeah.
And then you put a pile in, because you can drill that at open. And then lagging was a little bit cheaper. Now I understand the labor concern and, the speed of caisson walls might have had something to do with it.
Yeah.
But you've seen a lot of big concrete pours, right? Like you're talking about
Yeah.
1 meter walls in front of your caisson walls.
Yeah, 1 to 1.5 meters seems to be the new standard for that, 20-meter excavation depth. Yes, it's not unusual to see the wall thicknesses get up to 1.5 meters. I couldn't imagine what's driven that change from, did you say 6 to 8 inches for the original Finch station there? 6 to 8 inches to 60 inches, 10-fold change in 40 years? I'm sure the loading hasn't changed that much.
And packed full of rebar, I often will remind listeners that 1,000 kilograms of cement is 1,000 kilograms of CO2 when it's made. Steel is a ratio of 1 to 7. So 1,000 kilograms of steel is 7,000 kilograms of CO2. And, my passion is to reduce footprint, i.e. the name Footprint Engineering, the podcast Value Engineering Experts goes after this idea of over design and tries to have a little bit of a wake up call, at least commercially. I don't know if I could get through to the TTC, but I wouldn't hesitate to try. My theory is that some of these large engineering houses have consolidated and to win the bid, which takes some pretty big pockets to even bid this work.
Mm-hmm.
They team up with international engineers, but somewhere along the line, we think we're holding back water when we don't have to.
Mm-hmm.
And so I think you'd have to agree that the waterproofing and the argument, even on those subways that you've been in, Metrolinx,
Mm-hmm.
is that you have to take a water pressure on the wall, which is one cause for design enhancement, correct?
That is definitely one driving factor, yeah, or for what it seems to be. Even the caisson walls for Eglinton. I mean, part of the driving factor for that was, at least the stations I worked on were a top-down construction, so they did bear the loading of the roof to be dug underneath. So there was an end-bearing portion of it, but why couldn't that be caissons and lagging? I'm assuming for waterproofing reasons, or maybe there is some sort of rigidity concern there. I don't think I could speak to that from an intelligent point of view, unfortunately, but there was definitely a real concern for water tightness of the walls, and ultimately, design reasons, whatever it was, I don't even remember, utility concerns, there ended up being certain portions of these shafts that were lagged, underneath the utility crossing or something like that. And ultimately it did present no real concern of water ingress during the course of the excavation. So, you got 90% of this as a caisson wall, and then that final 10% or less than 10% is just lagged bays underneath a 100-year-old sewer or whatever it was in these different areas. Totally fine, no issue with water ingress throughout the entire excavation. So
you would do lagging under a sewer
in certain cases, under crossing utilities that just couldn't be staged around from the top side, basically.
The idea of decking, and this is not a new idea. I mean, people want to maintain traffic, and it's typically much faster to not drill a caisson wall and to let the soil drain. So I'm an advocate of drain conditions, which can increase, anchor adhesion. Right? And a lot of times it's struts. But in drain conditions, as proven by going underneath the sewer that you just talked about, there's probably very little water in that lag bay.
Yes, very little. The only place you'd really see it is probably in the bedding material around the sewer itself. And then beyond that, you're back into that, the clays that we're all familiar with, clay till, whatever you want to call it.
So these secant walls, again, with the European equipment and the operator-driven mentality of the Luffer casing, which is a sectional bolted casing system, and you can push that down, but typically you have to push that down when you're interlocking fillers. you have to
Yep.
push that down to the bottom of the footing, right? Because
Correct.
you want to, so
You need
then,
that full diameter all the way for the lock on the filler. Yes.
so where do you think they came up with, this idea of a base slab that would be 5 feet thick or 3 feet thick? Did you ever scratch your head and say, why?
Definitely. It is a cause for question, I think, a lot of the time. It was Finch Station on the York Spadina sub-extension. It was up to 10 foot thick in certain areas. And I think a lot of that, as it was described to me, was to do with basically ballast. So it's essentially weight to resist buoyancy. So some sort of a buoyant force that's going to be in this in the groundwater that's in the soil that would be capable of, I guess, lifting the concrete structure enough to create some sort of an issue. So that was one thing that was explained. Also, it's not unheard of to see micropiles put into these base slabs as well, again, to resist this buoyant force, which, I mean, again, just on the outside, and typically while we're doing these excavations, you're working within a dewatered condition as well, right? There's active dewatering going on around the site. So, maybe that's something to do with it, but it's not something that's ever seen this high water pressure. It's not seen during construction, at least in the shafts that I spent the majority of the time in. So this concern, though I'm sure it comes from somewhere valid, it is hard for me to understand or hard to conceptualize without ever having seen it in practice. Where is this huge water pressure coming from? How does it present itself? I don't know.
So for the benefit of our listeners, Toronto has gone overboard like no other city in North America. The desire to make a big deal that the Lake Ontario is in play when it's not, and the soil's always drained. If we go into Caisson Design now, in Toronto, Brendan, in the 80s, we used to put in caissons and get 7,500 kPa on per square foot. And then used to always send men down to clean those caissons.
Yeah. So
you'd go down there and you'd have an inspector go down after, and it was safe. There was never anyone hurt. So the idea is, you shovel that few skips, there's a small bucket in and out, up you come. The guy rides the bucket up and down. Now that practice, people thought, oh, that's unsafe, and safety became almost overdone in the sense that it's created a whole industry of safety people, and I'm safety first. I mean, we had a great safety record at AC Matcon when I was there, and today they still have Huddles and they do all those good practices. I mean, we would have Huddles before, a good contractor with a 4 or 6 man crew would typically want his men to talk about risks. They don't want anyone to get hurt. So there was these informal Huddles that happened, but now it became a little more formal. Maybe people had, brightly colored vests, and we try to reduce the deaths in construction over time. Which
I would say with that, I mean,
yeah.
I think everything that you described is true and it's valid. And if everybody had the same standards that the company that you were working for in the 80s, if they upheld that same standard on their own, we probably wouldn't be dealing with it. But I think a lot of that, the need to kind of formalize these safety huddles and all that sort of stuff probably comes from the fact that, some companies were great and were doing it at the time. And some people were, show up on site and get to work straight away. And, there's no discussion, there's no conversation, there's no planning, things like that. So, I mean, although the more anything gets formalized, the more of an impediment it can seem like to productivity. But in reality, I mean, I think we're doing a lot of the same stuff that was probably always done. It's just bringing the bar up here so that everybody does it at the same, to the same basic, level that you may have been doing in the 80s.
Yes, I agree. And maybe the larger market, there's been a lot of building, and the new contractors that come on stream are trying to survive with their first drill rig or whatever that can be. But I agree with you on what you're saying. So let's say in a caisson, we would do 75 tons a square foot.
Mhm. Are you
And
talking,
now-
sorry, surface or?
End
End.
bearing, end
Okay.
bearing. Yeah.
Okay.
So
That makes more
we
sense.
never really tried to get socketed in. I mean, there was rules of thumb where, oh, well, let's try and get a couple feet of rock, and the rock gets hard really quick in Toronto. Usually
Mhm.
hit a limestone layer and you're pretty good. And it's never failed at 75 tons a square foot, 7,500 kPa.
Mhm.
And yet now today, because, oh, well, we're not going to go clean the bottom, we're now at 5,000. That's significant.
It's significant. I've also seen a lot of recently, like very recently, I've seen a lot of a change towards this kind of these mechanical inspection devices. So your SIDS, squids, all that sort of stuff. That's basically, part of it is like a camera inspection. And then some of them are an actual, a measurement device that's put on the Kelly bar of a machine, sent down to the bottom of the hole with pressure pads on the bottom of it. And it gives you basically an indication of how much loose material is left on the bottom of these holes after your mechanical cleanout is done. So maybe
the idea would be, yeah, I would argue against all those things if I was trying to make production and someone's trying to do that to my job. I'm sure you did as well as a superintendent.
It can be painful. It can be painful, but you got to look on the bright side. Maybe that brings us back to where we used to be in terms of kind of curbing some of that over design, right?
Yeah, but they're still at 5,000 in rock, right?
Yeah, and I'm sure there's nothing that's going to bring that back to 7,500 probably.
Well, why can't we load test? One of the piles I just posted on LinkedIn today, actually, what is it, April? We're pre-recorded on these things, and this is not April, this is May 18th. So I have a look at the LinkedIn later, combined modulus pile. So in a drill open condition, which largely Toronto is the minute you put a top liner in, you could put clear stone at the bottom, tap it with an HSS section, and put concrete around it through like a piccolo tube tremie.
Yeah.
Now that's potentially 300 or 400 ton pile. We've gotten into the mindset of testing micropiles, and everyone fell in love with micropiles, where the capacity is being developed on a skin friction basis. And so why can't we do skin friction in soils? And by putting the gravel at the bottom.
Are you familiar with Load Cell, the company Load Cell, and they have like basically it's like a hydraulic ram that's put into the bottom of some of these caissons. Phenomenally expensive. It's probably not going to float your boat in terms of the initial value engineering, but they have these very, very sophisticated ways of load testing caissons now. That's again, it's to think of the cost of one of these test piles, because they're basically sacrificial once they're put in. But you can get very good information back from them in terms of end bearing and skin friction as well. They basically measure pressure down and pressure up and the differential between them.
So we would always look at I did a lot of load tests when I started Aecon. It was one of the sources of advantages. We even did bells, and we would do hand dug bells, and this was very common in the 80s. Young Langton, we would do hand dug bells, 6-inch bell in the sand, and Tro, and some of these engineers would say, okay, yeah, you got a bigger area, and you go down and clean it. It's just interesting how it's evolved to cost the planet more. Yet the buildings never fell down in the 80s. That'd be
true. Yeah,
and
that's a good argument.
A soldier pile, in Toronto has never broken. There's never been a soldier pile break.
Yeah. Do you know off the top of your head, what were the deflection criteria like back then for your shoring walls? How much is that?
Yeah, typically they were always driven by property owners next to shoring walls. So, if you cracked a guy's building, that wasn't good. And not to say we did crack buildings. I mean, we would often clip the footing to support the footing on the soldier pile. I don't know if you've done much of that, but we did a lot of that. If we were down at, with an old building at Jarvis and down in that area there, downtown, those old buildings, I would always clip the footings, and we would use green lagging next to buildings. cheaper. And surgical excavations often were enabled by those means. And we would actually jack we actually used to do drilled underpinning.
Okay.
Where Dave Miller, showed me, those techniques where you would drill, maybe with a 30-inch auger on a 10-degree batter. And then as you come up, I'm sure you've done it with deep, as you come up, you ream the back of the hole. Have you done that? Or did they
No,
get
I
rid of that?
never have done any underpinning, actually. No, I've never
No.
worked on
So
underpinning.
drilled underpinning was interesting. And I've seen piles. The best I've seen is a 24-inch pile put underneath a footing with drilled
Wow.
underpinning. You do a bit of handwork initially, and then you mine and you ream up as you go up.
Yeah.
Now, these techniques, I mean, I could still do them. So I don't really understand why they don't do them. But I think it's always about this Luffer rig
Mhm.
that doesn't cant back on the way the Watsons did.
Yeah.
And it would drive the solution into a certain mode of thinking. So what I'm advocating is always value engineering, in the sense that before you start a job, before you commit to the paper and the permit, why not meet at a preliminary phase? That's typically what the SAVE International process is. And they have a facilitator called a CVS, Certified Value Specialist. And they try to look at what the existing solution is. And then they throw that out after 3 days or 4 days. And they say, forget about that. Now, what are we really trying to do? So that's very, very effective for getting people out of the mode that they're in. And yet we don't seem to do that. We just seem to think that the engineer, if he's a big engineer, he must know. And so contractors aren't as vocal. They don't propose the design builds the way we used to. And it's really just a case where they accept the structural engineers. Oh, I don't want any risk. Well, at that point in the meeting, can you suggest another meeting where you're looking at the risk and trying to qualify it a little better for the guy? Again, no buildings have ever fallen down. We had a little bit of a meeting with Ziggy Zudak not long ago to talk about the bathtub solution that I'm advocating on commercial work in Toronto, where we drain the shoring and recognize the soils for what they are. There is progressive clays with depth and hard rock down there. Drain that off and get down to an R51. And, we on a P4, we can save on a couple acres to $10 million. So
yeah, amazing.
Yeah. So I'm talking to GFL and actually HC Macon now. And
Okay.
trying to license those two guys, because I think it's wise to have two prices and to have quality contractors. And then my dictate on the patents that I'm putting out are you got to have owner QA, which is largely a good idea for the owner anyway. I just want to get the reports, but and try to put a process in place where I don't have to drive downtown, Brendan.
Yeah, absolutely.
I'm out in Godrich now, and I've had it with the downtown traffic. So
gas is $2 a liter as well.
Yeah, there you go.
Yeah.
How's your coming back to Toronto? But Vancouver would have had busy commutes for you, right? So
Yeah, I never found Vancouver as bad. I mean, when I was out there, and I don't know if this is a little bit of the Torontonian in me, kind of being a little bit snobby about traffic sometimes, but I know when I was out there, people used to complain about the traffic all the time, and I never found it too bad. But I've always had a policy of kind of, if you live downtown, you're never fighting traffic, right? You're always going the opposite way of everybody else. So I know I did the same thing when I was in Vancouver. I'm doing the same thing here in Toronto. I live kind of close to the beaches right now in Toronto, which is not downtown, but it's close enough that when people are coming down to the offices in the city, I'm leaving and going somewhere else, and vice versa at the end of the day. So traffic hasn't been too much of a problem, and definitely Vancouver, I never saw it, to the same extent that we see it in Toronto, But I don't spend a lot of time on 401, so I guess I can't sympathize there.
that's like value engineering where to live.
Yes. Absolutely. Yeah. Your time is worth something, right? People think about those property prices, but your time is definitely worth something as well.
Brendan, there's not many engineers, civil engineers, that have done the degree of field experience you've done. And I would encourage you we could talk a little bit about what your goals are now. I mean, I would encourage you to take that and give it back a little bit in terms of, can you affect value engineering? What can be done, what's been done. And, if you get some gray hair around a table and you're in a position to, ask people who've been around, for instance, a company like Ishuit has, I think Chandra is still working. I mean, Chandra worked with Roy Walker. Have you ever met Chandra?
I don't think so. No, I don't think I have. No.
Natter's got a wealth of gray hair in that company, but the people that were around remember they'll do what the owner wants and they'll do what the structural engineer wants. And in the case of the presentation we did for Ziggy Sudak, they saw a lot of potential in what we were talking about, but they weren't quite wanting to be the first one. Even though
that's always the hard part, right?
Yeah, I guess so. That's what
Someone's
I'm finding. But, the fact is you're not the first one. Just go into the first Canadian place. I mean, they lagged that. They didn't Caisson wall that.
Yeah, I think we brushed on some of this in the past, but back at the beginning of this Eglinton Crosstown, we had a project there. This is when I was still at Deep, removing some of the old beams that had been put in back in, I want to say it was 95 when this project was first put forth. So, you're in the same ground conditions that we were going to end up working in to put these launch and extraction shafts in afterwards. And you're able to see, clear as day what was the shoring design in that area, 20 years ago at that point, or not quite 15 years ago. And you see, we're pulling out 18-inch beams at 100 pounds per foot, and then later, replacing them with 24-inch beams at 150 pounds per foot. And it's just, a caisson wall versus a lagging wall, exactly the same thing that you've described already. And it's just, it's a little bit disheartening sometimes. What's the difference? What's changed in the last 15 years? It's all the same low rise, residential and commercial in that area. It's obviously the same ground conditions that were there 15 years ago. So what changed? Why do we see this continual increase in all the use of concrete and steel? And are we ever going to be able to turn it around again?
Yeah, well, I would encourage you to keep asking those questions. And even if you're in a lagging situation where it might be a half of MPA grow, when you pull that steel out, you probably still see paint on there from the used beam that used to be in the weld. Yeah, it doesn't break and whatnot. With my nowadays, you see a lot of steel seconds because of the volume of steel. You don't really buy used beams. You don't have a source of demolition for used beams the way we used to. Yeah. So you end up with mill seconds, which are well within spec for shoring and a high quality steel, not A36, but G40 or 44 or better. We can take an 18 at 45. And we can put it in a P4. And when we do our bathtub solution, we weld tabs on there. I don't know if you've ever seen the way we used to do it at Matcon. We did a single layer and we would replace caisson walls in those days with it. But the double layer of waterproof shotcrete. So what I've developed is a waterproof shotcrete, and I use Aquagel slurry with E5, which is an amazing product, Joe Shetterly. And mag oxide, and I'm dimensionally stable. I end up with no cracks. We put a double 5-inch layer on, so then the first layer is bonded to the weld tabs, which are like Nelson studs, only hold, and that creates a composite beam action. So we don't even count that, but the potential is to save the final wall as well. So this is for a commercial owner who might have to put a scratch coat of shotcrete, which wasn't around in the 80s the way it is today. The final walls are done with shotcrete. So
do you see any savings in terms of the final waterproofing that goes on a building afterwards as well? Yeah, because that seems to be another interesting, for lack of a better term, industry that's popped up. This the use of this waterproofing systems.
If concrete doesn't crack, it is waterproof. So a 1/4 inch of concrete that doesn't crack is waterproof. It's very low permeability material. So we're going through testing. We've got more testing going on at Peter McCallum Labs in Hamilton right now. And with our Feng Mix 1, which is probably a 200-year mix. So I'm offering to take the warranty for 15 years that they they have in Bentonite systems. And you know, with Bentonite systems, they upcharge for a leaky anchor.
Mhm.
So we won't have any leaky anchors because before we put the shotcrete on, we put 18 inches of engineered drain board every bay.
Mhm.
And so you drain so there's no risk to taking the waterproofing warranty. So
You're not fighting it.
we wouldn't even have waterproofing, to be clear.
Mhm.
We're
Yeah.
advocating go for the maximum savings for the
Yeah.
developer.
Yeah.
And if somebody's prepared to give you the warranty and come back and crack inject if you need it,
Mhm.
but you won't need it. You know,
Mhm.
I've done these systems. I've seen them work in the soils of Toronto already. There is no water on a standard layered bypass system. There is no water left. So anyway, it's exciting. And you know, to go after the over design seems like a life purpose for me. I trying to be as respectful as I can to engineers who mention risk, but when it's a large engineer and they're representing a budget that, quite frankly, is probably delivering for them fairly large fees. I mean, if you
Mhm.
look at a P3 subway job,
Yeah.
they say that the engineering component of that, and you might know in some of your bids once you get into the estimating area with Aecon, if you do, but they would take, you know, 8% fees
Mm.
for design on the materials
Yeah.
and then they just produce these. They don't do any engineering, so they just reproduce a 1 meter, 3 meter wall with micropiles at the bottom. Hey, we did it
Yeah.
over here.
Yeah. It'll work
Yeah.
again. Yeah.
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 I don't doubt that there's no leaks in the subways today,
Yeah.
but there's no leaks in the subways in the 60s either.
Yeah. Yeah. That's true.
And
That's
they were
true.
drained behind. They were drained. I mean, the lagging was a natural drainage. And the fact is, the soils, you can get pocketed silts in Toronto in certain areas, but we're well aware of them, and it's not the end of the world.
Absolutely.
Yeah. In any case, so you know, I would encourage you to, as an engineer, to get varied experience. You've got some good contracting experience. You know, have you ever thought about getting into, like, before it's too late, because you know you seem to be got the work ethic. Well, you know, what about, have you seen any engineers that you've worked with at Deep that went into design after?
I can't think of any off the top of my head that have successfully. I shouldn't say successfully, because I can't think of anybody full stop that's left Deep to go into the design aspect afterwards. There's a lot of crossover, I guess, back and forth between the field and going into kind of the fiscal management of job sites. But actually, I shouldn't say that. There's a older gentleman from Isherwood that we used to work with all the time, a fellow by the name of Ed Kolakowski, who I believe used to work for Deep Foundations a long time ago, and had kind of gone back to kind of his engineering roots afterwards, after a long period in the field. So, you know, that's kind of one of the few examples I can think of. Having said that, I can't see why it couldn't be done. I definitely do have an interest in that as well. I just really enjoy the field work. That's the only problem. That's the thing that holds me back, I guess, is I really like it. You know, I like being outside. I like working with the guys. I like working with the equipment, and you know, there's always something to be said for further development, but there's also something to be said for enjoying what you do every day, and waking up and enjoying your work as well, right? And so that's kind of
close to home downtown. Yeah, that's,
yeah,
life
exactly.
is good.
Yeah, exactly.
Yeah. Well, it's you know, I've never regretted moving around a bit. I did general contracting and civil engineering. I wanted to shock my system into other learning curves, but you know, I was a bit unique, and I stayed very operational through my career. But if I had to do it again, I would probably be open to the design thing. Although I don't know how long I would stay in that mode. Like you say, you get attached to the equipment, and it's really being attached to being an expert. So
that's a good way of putting it. Yeah, there's definitely a pride that comes with something like that. Absolutely, can't be ignored. Yeah,
I would imagine Aecon plays pretty good money. I mean, they must have hired you away from, in the market today, it seems like a senior superintendent of your caliber would do quite well financially. If that's what it's all about, but you also put in longer hours, right? I mean,
I was just going to say is it's not always the best work-life balance working in the field. That's probably the only drawback I can think of. It's not always the best work-life balance, but that's like anything. I think depending on your personality, you can force yourself into a poor work-life balance doing almost anything if that's your nature, right? But it definitely, the field work does demand a lot of your time. And I really don't think there's no two ways around that. That's just a reality of working in the field. So there's always something that happens, especially if you're pouring concrete every day. There's always an unexpected surprise, right?
Yeah. Well, you get invariably as a superintendent, you like to be there right to the end for safety reasons, and also to make sure the pour goes okay.
Exactly.
Could be that that's where engineers they frequently. Why do you think it is that engineers either do a very short duration in the field and then aspire to go into the office after, let's say, 2 years?
Well, I think it could be a lot to do with that. A lot to do with the desire to get out of the mud a little bit and get more stability in terms of your schedule and things like that. I could definitely see a draw in that direction. And I guess it's the same thing you touched on before as well. It's you want to get a breadth of experience, right? You want to see a few different things. There's only so many holes that you can drill on the ground and be excited by, right?
Have you ever lost a hole? Have you ever had a foundation that? I'm just curious.
I'm trying to think. I've definitely had to re-drill a hole in the path, like backfill and re-drill one. I'm trying to think of specifics, but probably high water pressures, mobile sand, something like that. Some sort of an unsteady base, something to that effect would be probably the only time I can think of losing a hole. Maybe with some slurry drilling as well. You get a risk of instability. Sometimes that's enough to pull the plug if you feel like you're potentially going to introduce some sort of a stability issue at surface, or create a void or anything like that. That's definitely a time I can think of maybe being a little bit overly conservative in the interest of safety and pulling the plug and trying to backfill something to make sure that you've got a clean bore to drill the next time. But in terms of losing a hole, I mean, rare, yeah, very rare. Out of a couple thousand, I can think of maybe one or two cases off the top of my head that are a time that, and maybe you could have risked it, right? It's always that what if after the fact. Maybe you could have gone for it and made it just in time for concrete or something like that. But no, there's definitely been a few over the years that have been a high enough risk to backfill.
Yeah, there's every technique has its knowledge base, and the person bidding it doesn't want to be responsible for the financial loss for the company if they didn't bid the right number of holes per day.
Yeah.
So knowing the waste and knowing the risk. But I think out in Batula Bridge, you were saying that you were doing slurry, right?
Slurry drilling, yes. Yeah, it was a polymer slurry that was used for a lot of the drilling out there.
Which is trying to give you some surface tension in your drilling fluid, right?
Basically, yeah. It's it's a bit of a black magic from what I can see, but it seems to basically just gives you some stability in the ground to avoid the use of a temporary casing.
So you were then able to extract and excavate soils underneath the slurry.
Exactly. Yeah. Drilling under a liquid head.
And that in that condition was called for in all likelihood. That's pretty deep holes.
They were definitely very deep. There were some challenges as well in using that method, as there would be with a temporary casing. Absolutely. But in general, it worked quite well, and it is a very efficient way of working relative to a temporary casing. Definitely. I almost think the alternate in that situation is maybe more likely to be a permanent jacket or permanent steel pile, which are very common in the Vancouver market as well, which I believe has something to do with seismic loading.
Yeah. Well, the other thing you could try to do is be an operations manager. You've got enough knowledge and people skills. You could probably do quite well. I'm not trying to get get you hired away from Jonathan, but
I appreciate it. Thank
I
you.
know that I know your path, and I know a lot of guys have taken that path, and I would say you've done well, Brendan. You've come a long way since that call to Deep Foundations
Yeah. Yeah.
many years ago, and
It's been a
so
long ride.
So when I do the math, you're early 30s,
Yeah, mid 30s. I just turned 34 a couple weeks ago, actually.
34.
Yeah.
Yeah. Well, keep learning. It's been great having you, and maybe in another couple of years we'll do this again. I want to keep going with the agenda, impressing upon people that to practice value engineering at the start of projects, and to say why the existing solutions have to be done. A, because we did them with much less materials in the 80s. B, we have to save on materials because it's competitive, but also because the CO2 involved in the built environment. They say it's 40% of the amount of CO2 is generated by the built environment.
Really, I would never have thought it was that high, but I mean, it makes sense given the numbers you just talked about there. Yeah.
Yeah, I mean, transportation is a good part of it, but the highest component is, and if you equate things to a gallon of gas, it's there's a lot of savings to be had in a world of depleting fossil fuels. The idea of a Tesla car is it's actually coal powered, because in the States 30% of the energy is coal powered. So
how are you charging your batteries? That's right. Yeah.
Exactly.
And what are your batteries made out of? Yeah.
Yeah, exactly. So I think we're pretty good. Thanks for the time, Brendan. And if I can ever do anything to help you, or please call. And I tell everybody to if you've enjoyed this video, just press subscribe at the bottom of the Value Engineering Experts videos, and then Footprint Engineering, we now have our own following right there, and I tend to post there, and then also post to different groups now. And I've got I think I'm up to 13 patents, and I can't really see the point in having more, because there's a lot of work to get commercialized. And then there's a lot of resistance to just doing something that, quite frankly, is pretty damn obvious, right?
Yeah. Yeah.
Like, why not save the money? I'm telling you that Ford is out there building roads, and I wish that he had a little more attention to the taxpayers' dollars. I mean, all these I don't know if you saw the provincial debates the other day. Did you see that?
I didn't watch it. No. I
Well,
heard
they were just
I heard the
talking
Green
over
Party
each
was
other
a standout, apparently. But
who
other
can
than
spend
that,
the most? Right?
yeah. Yeah.
But on these subways, I'm quite sure I could get it done for half the price. So tell Aecon, right?
I will. Sounds good. Half the price means twice as many subways, right?
Yeah, we can do it for well, I can give advice for nothing. So I don't charge to be part of a Zoom or whatnot, as long as I don't have to drive into Toronto. Then I might need to charge the gas, but
That's it.
anyway, you have a good day, bud.
You too. Thanks a lot
for joining us, eh?
It's been a pleasure. Thanks.
Take care.